All right, today we're going to deal with units applied to particular physical dimensions that are commonly used in the U.S., United States, sometimes referred to as U.S. customary units. I'll leave it at that. And it is what it is. Basically, only the U.S. uses these units, and I don't know. Many years ago, when I was in school, we thought we were all converting to metric units, but it never quite seemed to happen. But someday we will end up probably losing these US units. But for now, if you're going to work in the US, you need to be familiar with them. So let's go through them. All right, so there is, as we talked about before, SI units, System International or International System Units, also known as metric units. And then we have what we call US customary units. The SI units are determined largely by various conferences and conventions where academics get together and try to form a system units that they are consistent and everybody kind of understands. In the US, well, there is a long history going back to the colonial times of when we set up systems of units, and it hasn't really changed, and I don't believe there is any overriding body that maintains how the units are used. But there is a set of customer units. I would say scientists in U.S. use SI, but engineers may use either. And sometimes it depends on your discipline or your client or other considerations. All right, so what are the kind of conventional US customary units? For mass, there's really two types of units. There's one called a pound mass. A pound mass would be equivalent, or a pound mass would apply a, how do I put it? If you had an object that has the property of 1 pound mass on Earth, then it's going to essentially apply a force. And if you put it on a table or on a floor, it's going to apply a force downward of 1 pound force. Okay, slug is another unit of mass, and we'll talk about a little bit about it more later. Length, we use feet. Time, seconds. Could also use, obviously, hours, minutes, days, years. I'm not going to go through that here. Thermodynamic temperature, remember we talked about it when we were talking about SI units relative to absolute zero. There's the equivalent of Kelvin, degrees Kelvin. In SI units would be Rankine, or an abbreviated as R in our unit system. All right, there are other. All right, so what are the U.S. customary units? Other customary units: force, pounds, abbreviated LB; distance, foot, abbreviated FT. Plural of foot is not foots, it's feet. Volume, gallons, which would be equal to 0.1337 cubic feet. Abbreviation G, sometimes you'll see GAL. Temperature, Fahrenheit, degrees F. And as you know, likely, freezing point of water is 32 degrees and the boiling point of water is 212 degrees Fahrenheit. All right, so other distance units to be aware of: inch, 12 inches per foot, abbreviated as IN; miles, 5,280 feet per mile; and yards, 3 feet per foot. Oh, there. All right, why do we have 2 units of mass? This is something that creates a lot of issues when people get into physics and try to use pounds mass and pound force in their physics problems, and largely I suggest you avoid that. In any case, on Earth, 1 pound mass, in other words LB with a subscript M, exerts a downward force of 1 pound. Obviously, if you go to the moon with that same 1 pound mass object, it's going to exert a different force. And one of the issues and why I don't suggest that you use pounds mass as a unit is that it's inconsistent with Newton's first law as written, typically F equals ma, which is force equals the mass. In other words, force equals mass times acceleration. That's the force that you need to apply in order to accelerate some mass up to an acceleration of a. So, for example, if you write 1 pound equals 1 pound mass, that's your mass, times an acceleration of 1 foot per second squared, that does not equal 1 pound. Typically, they use that equation and they apply a little fudge factor, a g sub c, like a conversion factor to get it to equal to 1 pound. But you probably want to avoid that. If you're going to do any kind of problems like this in physics or in any engineering calculations, use a slug. Although what I probably recommend is use SI units, which are more internally consistent. But if you use a slug, then you end up with 1 pound equals 1 slug times 1 foot per second squared. All right. Enough said about that. Use SI units. Actually, what I say here. Use that if you have any calculations involving mass or force like this, F equals m times a. It's problematic. I recommend you don't use it because frequently people make mistakes when they start doing that. Use newtons for force, kilograms, and meters in second in your acceleration units. All right, so temperature, we mentioned Rankine temperatures. There's also, of course, and Fahrenheit temperature. Rankine temperature is scaled to a relative to absolute zero, where there is no motion of molecules in a gas. And if you in order to convert Rankine and Fahrenheit, you just use these formulas. So you take if you're starting out with X degrees Fahrenheit, add 459.67, and you get degrees Rankine. Likewise, if you have X degrees Rankine, subtract 459.67, and you end up with Fahrenheit.